Good afternoon, everybody. I'm Dave Hyland, and I'm here with my friends Eddie Smith and Todd Fletcher, both from Versant. Today we're going to give you some insights and attempt an actual live demo on what we've learned about Rich Authorization Requests, which we discovered as part of designing a new digital channel for one of Australia's big four banks. About 18 months ago, I was working as the principal architect for open banking, and the institutional banking division of bank I was working for was looking to modernise their systems, and it started some design and planning work. One area they wanted to address was how to solve for complex customer entitlements. Thank you. With consent-based delegation. And they had some funding put aside to explore some new technologies and approaches. So given the experience we had in the open banking team around consent-based data sharing, and the expectation for further complexity coming into open banking to solve for the introduction of right use cases, we ended up with the funding and the objective to look into attribute-based access control and consent. So to help us along, we got Versant in to do some heavy lifting on some technologies we already had, but also to tap into some experience that they'd had working with other customers on this tech. So, good point, I need to do this too. Right. So, just to set the scene and help those of you in the room that aren't familiar with the history and complexity of banking systems and how their authorization capabilities evolved over time, I'm going to give you a quick primer. To understand where the complexity we face came from, you need to understand a couple of things. One is banking systems are old, and historically, the process of authorizing any sort of banking instruction all went back to a branch the account was held in. The branch held a signature card, which you filled in when you opened the account, which was then used to verify the authenticity and enable the authorization of any instructions that the teller then entered into the system. It was around these processes and these banking systems which had just basic permissions that the digital channels had been developed. So when these new UX technologies came along, banks started to provide new ways to access these systems like internet banking. These new channels wrapped around the old systems and included new entitlement models to let customers perform just the subset of things that they could do in their branch. Banks also used these new technologies to scale and support call centres to provide better branch functionality, creating staff-based entitlement models that optimised and improved the processes and limited what other different teams or user roles could do. Delivering these digital experiences to corporate customers also brought about the development of new entitlement models again, allowing these customers to manage what their own staff could do. The bank I was at had one of these channels. It was implemented in about 2000 and had been continuously enhanced over the years. And while the channel had some interesting features, it was role-based, it struggled to offer customers the sort of flexibility they need to manage their own corporate governance structures. And finally, most recently, open banking's brought about a whole new layer of complexity, requiring banks to open their systems to third parties via APIs and allow customers to delegate access to their accounts to these third parties. In Australia, like most of the world, this sharing is consent-based, and that brings new complexities, but also new opportunities to modernise the way we manage entitlements across all channels. So when we started looking at attribute-based access control for this new banking channel, we took a step back and had a broad look at the problem and how we could solve for overcoming the existing complexity of banking entitlements for large organisations that would allow those organisations to self-service their own user access and provide support for open banking and more general consent-based delegations. So the channel needed to achieve a number of things. We needed the star-based authorization because there wasn't going to be a single approach to authorization. This wasn't a greenfields platform, and if we wanted to ever achieve any identity federation with our customers, we'd have to support RBAC. There was also a reback requirement. To resolve what a user can do on an account, we require traversing some sets of very large relationships with thousands of accounts, each with specific ownership, and entitlements. And finally, we need to support ABAC to achieve the flexibility for our customers to customise the experience and create their own corporate governance controls. Next up, our objectives. We wanted obviously achieve a performance. Complexity comes at a cost, so to get fast authorizations, we can't rely on calls into source systems. We needed something different to address the performance overhead and keep the workloads away from older banking platforms. Consent-based entitlements, again, we can't avoid it for open banking. It actually provides us with a standardised way to manage entitlement delegation. So solving for consent-based access needed to be a big part of what we had. So with the help of Versant, we very quickly built a prototype using the ping stack to authenticate and authorise web client. We used ping authorize to address our RBAC ABAC requirement, hooking into ping directory to discover the group memberships of the user and the channel features they had. To address the reback requirement and mitigate performance overheads with resolving complex customer ownership problems, we dropped in Neptune Graph Database, which held a cache of the customer's legal entity and account structures from the underlying banking systems. And for consent-based entitlements, we didn't want to build anything too special here, so we leveraged the standard consent-based authorization capability that came with the Ping platform. All seemed to be going well, nothing really too groundbreaking, but when we began to look at authorising consent-based delegations for some large corporate customers, we started to see some challenges flowing the entitlement into the enterprise domain and down into the back-end systems. So the problem here is that not all users are recorded as parties in these back-end banking platforms. The actual owner that granted the consent is not part of the request. And the downstream systems know nothing about that sort of stuff, so we wouldn't be able to do any type of authorization down there. We were using token exchange to try to work around this, but when we tried to exchange the public token for one holding the information that our back-end systems could understand, things started to blow up. A get accounts request for a user that had been granted access to hundreds of accounts failed because the size of the token holding the information that the back-end systems would need wouldn't fit into the headers. Plus, the performance of that authorization decision also started to slow down. We figured the best way to reduce the complexity of the API request was to narrow the scope of the token that was used to request the resource in the first place. This would front load some of the authorization effort and reduce the work needed to be performed at the gateway in enforcing the entitlement and reduce the token size. So we've been previously looking at rich authorization requests for open banking, and we knew it gave us the ability to get a narrowly scoped token up front. So we pulled the standard out and gave it a go, and then we came across some interesting things.
Thank you, Dave. So we boiled it down to 5, just because 5 is a nice number for people to remember, and we take it up to 7, it gets confusing, and if we had it at 3, it looks like we haven't learnt enough. So at a very high level, the sort of the 5 things, and we're going to deep dive into these over the following slides. The first thing we did, and these are not in order of what we learnt them, these are more in order of how they appear in the session, so to speak, or how they appear in the flow. And what we're going to do is we're going to break after we talk through the detail of the first 2, and we're going to demonstrate those 2 in a live demo. Nothing like that for keeping you on your toes. And then we'll go through the next 2 and do another bit of a demo, and then sum it up with the 5th and last one. So the first thing we did, or the first thing we do as part of the session, is we worked out very quickly that it is difficult to create the token when you're not sure what you're going to do in the session when you're trying to minimise those scopes. So what we did is we bootstrapped with effectively a very lightweight authorization request, effectively of nothing, right? Then what we also learnt was by using the tokens and having these discrete tokens, we're able to answer the question, what can I do, not can I do this? So it really sort of enabled us to drive some different behaviours, being able to answer that question versus the sort of traditional request and 401 type responses that we would usually get in these examples. The other thing we were able to do when we started to scope the token down and filter it down from the thousands of objects that we had with some of the larger mining customers, specifically in Australia, is we got to a concept we called exact privilege, which is below least privilege. It was just the exact privilege we need to perform the transaction at that point in time for that client. So we're able to scope the tokens down to almost components on the page, which then helped us with user experience in this case, because we actually had tokens that would be able to drive the UX of the discrete components within the front end for the end user. Right. What we also finally learned is life would have been a lot simpler with grant management. Grant management, relatively new spec. The implementations are a little mature. Grant management lets us query what we're allowed to do from the grant management API without actually issuing a token. Unfortunately, with the implementations, when we were running the POC, they were very new, so they didn't exactly give us what we needed. Hence, we're actually in the demo getting a lot of our data direct from the tokens. And if we had that grant management capability, life would have been a lot simpler. So bootstrapping the grant or bootstrapping the session, effectively what we did here was we set up, as you can see in the bottom half, just literally an authorization details with just the immediate structures we needed. And we basically set up the scaffolding for the session that we can then use later on in each of the different interactions. We sort of then took the wisdom that this is really secure by design because we've set up a token with zero privilege. But we also enabled us to keep it simple. So what we also determined was that authorization design becomes extremely important in this instance. How you design the grants, how you design the permissions needs a little bit of forethought, because you can end up down a rabbit hole with applications calling and leveraging these and they're not quite what you need. So understanding how you need to authorize and what you need to authorize is sort of something very important to get done up front as part of that analysis. What we also got was we actually started shifting the authorization out of the authentication flow. So we pushed it down a little bit further by bootstrapping the grant with zero permissions. And we were able to push the authorization or the token generation for those specific authorizations further down into the session, not as part of the authentication flow. In terms of allowing the what can I, as I said, it was just beyond the can I do this. Because the tokens have a specific set of entitlements, we're able to see exactly what I can do with that token at that point in time. And the token provided the actions that you're allowed to do. So it's almost like Hateos in a token for what you're then able to do within the discrete components. And as you can see, the authorization details just started to expand. And then when we start to make the request in the next stages, it filters back down. What also occurred to us is almost like we had a distributed policy information point. So because we're embedding this information in the token's for a specific transaction, as we pass this along, we're actually got a distributed PIP that can be trusted by each end of each point in the actual request flow. And it's almost, we sort of thought we'd use the analogy, it's almost a verifiable credential for a request, but we thought we're crossing a few too many boundaries there, so we sort of kept it as a distributed PIP. Now what I'm going to do is we're going to pray to the demo gods, and I'm going to hand over to Todd. Todd's going to demonstrate the bootstrapping of the token, how we achieve that, and then we're going to demonstrate having no permissions and then going through and having some permissions when we load those in. And let's hope that the flick button works.
All right, let's light this candle. I sacrificed a pile of goats outside earlier, so it should be right. Okay, welcome to Yeah Nah Bank. It's the classic Australian parlance. Instead of saying yes, no, yeah, nah. All right. Let's get cracking. So, just a brief overview of how it works. We kind of got client connected to AS with a banking API, which hooks into a PDP, and there's a consent source sitting in there as well. So just some simple things, right? Bootstrapping, why do we bootstrap it? We don't want to blow the token size out. As Eddie mentioned before, we kind of did a couple of times, and it wasn't great. But anyway, so I hate talking, so let's get on with it. So I was looking as Joe, and fish. Phew, it works. Right, there you go. So Joe has no consents available at the moment. There is absolutely nothing in there. There is nothing he can see, nothing he can do. And I did almost absolutely crap my pants when it took a little bit to come through. That's so fantastic. So, no transactions. I can't do anything. This is what I like. Debug tokens. And we don't really have too many things. So we see we have the bootstrap. We've got the bootstrapped auth details there, where we have two types. This will get interesting in a minute, in the next part. So, for the moment, we've only just got an original token, and we've got the refresh, and then we've got the token claims. So, nothing I can do, so I'll log out. What I'm now going to do, let's create some consents. I tried to create an admin interface, but that just took too long, so I've just got an LDIF. Yes, LDIFs are the best. Let's just dump that in. Now, as we can see, so this is where we've got some of the information in here. So this is where we've got some JSON blobs that have kind of got the stuff, which is good. So we'll log in. Yeah. All right, let's log in. Log in as Joe. That's a bit different. We've got some accounts. I like it. If I click on them, nothing really happens because I didn't hook it into the balance database. I just ran out of time. But if we click on debug transactions, I've got some new things. And we've got some accounts with limits and permitted actions. And now I'm back to Eddie.
Throws the switch, Igor. Okay, that was the demo bit. Okay, and as we can sort of we're starting to see, what we've done now is we've actually got our Uber token, which has 0 standing privilege, security by design or by accident, as the case may be. And then what we've done is we've actually used that to refresh and get micro tokens or specific tokens for specific actions, or that's what we're about to do. So the bootstrap gives us effectively the coarse-grained scopes to say what APIs we can call, but 0 detailed entitlements. Right? We then work out what we want to do and we start to request the grants for the specific actions that we want. This is where normally, as Todd said, the token would have blown up when we get the accounts back. But what this does is it gives us the ability to work around that. If we had the grant management API working, this is also the point where we would have called the grant management API to be able to get what we need. When we looked at token sizes, we looked at all sorts of things like trying to paginate a token. I wouldn't recommend that. That's just a source of heartache and pain, but constant amusement for me because Todd was doing the engineering. But it really does give us those, now that we've worked through the RA requests and we've swapped the RA request with a token, with a refresh token versus a token exchange to get specific micro tokens with the specific RA information in, we now have a token for a transaction, which is what we're going to dive through in the next part of the demo. Right, this is also driving the user experience. So this is kind of what became quite interesting. When we have all this extra information about approval limits to and from accounts, we could add currencies, we could add times of day. We are able to drive the UX and display information in real time back to the user. We'll then show how you can actually tweak the UX if you're a not particularly friendly user and try and bypass. But it's the same token that's being used in the decisioning point that's also being used to drive the user experience. So we'll just hand back over to Todd to sort of show how we could get the micro token. We're then going to post back and we'll do a couple of error things and away we go.
All right. Time to, hopefully that second pile of goats is burning in the car park. Let's see how we go. So transactions. Let's click one of these guys, eh? Let's click on that one. Let's pick on the new victim. Destination account. That field doesn't really matter. I want coffee.
Real coffee.
Yes, Australian coffee. Oop. Now, I'm just going to enter random amounts and then just go submit. Now that's interesting. This is actually being driven from the auth details that we got back. So as a part of the RA, or a part of the auth set details, that we've specifically got just for this account. So now if I was someone who is quite intuitive, and then we go into here, as all of us are very good at modifying HTML forms, we can see we have this max field. I'm going to delete that. Huzzah, fantastic. I am now going to be able to go through and bankrupt my company because I am about to spend over $6 million on coffee, which is a great day for me. However, limit exceeded. So that's been rejected by the PDP because we're submitting that new token, only that specific operational token, to it and comparing it against the payload that the PDP received through the banking API. And that's how it works.
There's a surprisingly large amount of work in those 4 pages. Underpinned by 9 components, I think it was. Okay, as I said, probably the thing that would have made life a little bit quicker would have been the grant management API. It's a relatively new standard, relatively immature support in the products, but that was sort of the last thing that came up is, do we write our own grant management API to get the information we need to stop having to pass the information through tokens so we can make API calls? If you had APIs that could access that, you could achieve the same thing. Final thoughts, because we're getting close on time. What also occurred to us during this process flow and as we were doing things is the role of the PDP and the authorization server is blurring quite a lot. So in a couple of instances in the very early days, we're reissuing tokens from the decision point, and other times we were making authorization to decisions in the AS. So those two really are blurring in the way it's working. We also had to start thinking about our authorization from the third person perspective. So it was really, what can the app do? What should the app be doing? And that was also part of that, how we had to start modeling the authorization process. And some sort of signalling from the PDP back to the client, etc., when things change. While we've got this end-to-end flow and these tokens flowing through transactions, we started to look at where signalling would be able to help. And, we're not sure what sort of signalling. We didn't get to that in the proof of concept, but it was something where we thought that would be actually quite useful to be able to signal steps during the process flows. So important, we had to say it twice, the impact on the digital experience that this can bring. It really does let us start to change the way identity helps within things like digital experience and provide greater feedback, and move to more granularity beyond 401, 403 type errors. And it lets the UX just provide that information a bit more real time and better user flows. And as I said earlier, sort of component-based UX design with tokens that map directly to those capabilities or to those components. Final thoughts. It's a journey, not a destination. You always have to get a cliche in a presentation. We mentioned the Grant Management API, and it really did feel like a VC for a transaction when we were doing for these things. So, the next iteration of the POC will be how can we use VCs issued by a company to then take that to the bank as part of the authentication flow to get a micro token or to get a RA request moving along, and the merging or the alignment of those two worlds. As we said, how do we get signals back to the client? How do we tell when something's changed at the back end or 3 steps into a transaction flow in a large complex banking environment? Dave was very polite to the banking environment. To say it was old would be somewhat of an understatement. Prehistoric's a nice word, I think. But just years and years of legacy building. As we also said, great modelling, just designing and giving enough thought to it all up front. Very important capability. And then token exchange still has a place. It just wasn't appropriate for what we're trying to do, and how those two worlds sort of work together with the RA request and with the token exchange is important. And the last but not least, if you're interested, there is the AuthZen working group. For those who are in the Southern Hemisphere, it's at 3 a.m. So I'm not interested enough. Dave is, but I'm a little older and need a lot more beauty sleep than Dave. And with that, thank you very much. We'll open it up for any questions. Or further demonstration, if you'd like. Plenty more goats.
All right, gentlemen, thank you very much. Great session. We have a few minutes for questions, so raise your hand. We'll bring you a microphone. Got you in the back.
We got one. I'm impressed.
So, to what extent do you guys have the ability to control or enforce the limit of grants that are provided as part of an individual micro token, right? You have these limits on token size. Is that how you tell someone, hey, you've requested to do too many types of things with this token? Or can people get themselves into trouble? How does that work?
Yeah, I think I skipped over it. One of the things that we did work out quite quickly was that an SDK would be very, very handy for the end developers to do with the token management, because you do end up with while we haven't exploded a token, the number of tokens has exploded, so to speak. So you do end up with a lot of different tokens and an SDK to help manage that. Did we put any controls on what the client can request? No, if they said, give me all 4,000 accounts, it would have still blown up. We didn't get to that level of detail. But how you then authorise the authorisation is probably the next level of detail.
A really quick follow-up on that. How much would, for example, in the SDK that you're providing to these developers, is the SDK responding to things happening in the UX and automatically provisioning or requesting new tokens versus when developers have to be like, oh, you came here, so I think you're going to need this, so let me go get that token first and then attach that to the request now. How much is on Rails versus they have to figure it out?
Yeah, what we worked out is developers love token management, so we want to let them do that as much as possible. No, it was where we were looking at the SDK, it was really more just around the token management, token request, just simplifying that so that they didn't have to deal with it.
But there is something there as well with the Open API spec as well.
Yeah.
These RA types should be basically assigned to each of those APIs. So you kind of could almost generate a lot of information off an Open API kind of swagger, and that would tell you where and when you can actually use it. So therefore,
so it's almost metadata for the API itself. That makes sense.
Yeah.
I can give this to someone else now.
Thank you. More questions? Time for one or two more. All right. Thank you all for attending. Enjoy the rest of the show.
Thank you.
Good one, boys.